Welcome to another machine learning video. So in this video I want to implement a machine learning algorithm called XGBoost, and I want to implement it in a classification task, but this one can also be used for regression tasks as well. So this is also another boosting algorithm, and I think the full form stands for extra gradient boosting, something like that. So let's get started. Let's import record libraries. Let's import 𝐿SPD. Then import matplotlib. After that, from sklearn model selection, import train test split. Then I need to import XGBoost. This is the Python API. So let's also check the version of XGBoost. And finally, I need to import metrics from sklearn. Okay, so the version says 2.1.1. Let's now load the dataset. So the dataset I will be using is called banknote authentication dataset. So let's load it. bd.bit.csv. Okay, so I have loaded the dataset. So it has 4 features: variance, skewness, kurtosis. These are all statistical terms. Another is entropy. Entropy is used in many fields, for example thermodynamics, information theory. I'm not sure what does entropy mean here. I think entropy is also used in decision tree, in like stuff like Gini impurity or something. So let's check the shape. So it has 1372 rows, 5 columns, 4 are features on its target. Let's check the unique entities in our target column. So it says 0 and 1. Since this is a banknote authentication dataset, so I believe this means fake or real, fake and real, but I'm not sure which one is fake and which one is real by looking at 0 and 1. We can also check the value counts. Okay, so 0 is present 762 times and 1 is present 610 times. Okay, so now let's separate JSON classes. So I want to drop the last column from the features, then select the class column for the target. block, then onto the data set. So string test size 0.25, print size 0.75, random state 1. So we have over 1000 samples in the train set and 343 samples in the test set. So since we separated, then we can apply our algorithm, which is XGBoost classifier. So we can call it XGB. Then I think it has so many parameters and estimators, the max depth, max leaves, learning rate. So many parameters are present. So I am to change a few parameters only. So in estimators 50, max depth 5, learning rate 0.5, random state 1. Then we feed our training data to it. Okay, so we have already fitted the data. You can see the various parameters that it has. So I have only changed this one, this one, this one, and this one. Okay, so now you can check the accuracy. So not matrix xgb.score. So we can check the accuracy of the test set. Oh, so the accuracy on the train set is 100%, and the accuracy on the test set is almost 99.5%. So I think this algorithm is little bit too powerful for this data set. Anyway, we can plot the confusion matrix. For the X test, display labels, then this plot, color or false, then I have to add the labels. X ticks, Y ticks, and this will be title. Confusion matrix. Ground truth. And this will be Y label. Okay, so this is our confusion matrix. So we have almost everything correct, only one wrong prediction here, one wrong prediction here. We can, I think, confirm the value counts. So in the test set, 0 is present 193 times. We got 192 times correct, and 1 is present 150 times. We got 149 times correct. Okay, so performing very well this algorithm. Let's check few other metrics. We have F1 score, and checkered score. These are also very high because we do not have many wrong predictions. So we can also check the classification report, which I believe also will be very high. Okay, so it says everything is 0.99 good. Finally, you can see the feature importance. So XGBoost dot importance. Okay, so this is our feature importance plot. So the most important feature is kurtosis, this one, then variance, then skewness, and least important is entropy. Okay, and these are the feature scores, which says F score here in the x-axis. These are the names of features in the y-axis. Okay, so probably we needed to use a little bit more difficult dataset for this algorithm, but anyway, we got very good results. So I think that's the end of this video. Thanks for watching.